So good evening my students. So welcome back to my channel after a long time. So I hope everyone is fine. Okay. So as a topic, okay, what are the topic we have taken for today? You can see here on your screen. It is related to your computer science class 11. These are the fundamental things of computational thinking. These are the fundamental things of computational thinking. What do you mean by computational thinking? Let me introduce to you. What do you mean by computational thinking? So we are solving different kind of problem. We are solving different kind of problem in our life. Yes or no? So same thing, we need to solve some computer science related problem. We need to solve some computer science related problem. Is called computational thinking. Remember? Okay. So for solving the problem, we need some steps. Solving some computer science related problem, we need some steps. So what are the steps and how to follow that step? What are the criteria to follow the steps? Everything will be covered on this video. So the first thing is introduction to problem solving. What is problem solving? Steps for problem solving. What are the steps to process problem solving? Then analyzing the problem. Okay, what are the different problem is coming, we will be analyzing. These are the steps you can see here. Analyzing, the first one. Developing an algorithm, coding, testing, debugging. Okay, these are the steps we are going to follow for solving a particular problem in computer science. Solving a problem, we need to follow these steps. Okay, then representation of algorithms using flowchart and pseudocode. What is that flowchart? What is that algorithm? What is pseudocode? That should be, we should know very soon. Okay, so let's start our class. So first thing is introduction to problem solving. So problem solving is a systematic process that involves understanding a challenge and working towards an effective solution. So what we can see here, normally in real life, what is the problem solving process? If we'll go in real life, it is a systematic process that involves the understanding a challenge and working towards that effective solution. Means we need to analyze that why this problem arises and what is the solution for this problem. That is the main thing to solve a particular problem. So in computer science and programming, problem solving follows specific steps to ensure the solution is logical, efficient and error free. So if we move to the computer science field, if you are getting any kind of project, okay, if you are getting any kind of project in the company, then what is your task, what you need to be do. So the thing is very clear that you need to find the solution, you need to develop the project, and that project should be efficient, logical, error free. That should be logical, okay, logical, and that should be efficient, that should be error free. That is the main motto of the problem solving in computer science field. We need to develop the software that should be efficient and error free. So in this we need to solve the different types of problem, okay, in computer science field. So now we'll move to the steps for problem solving. The first thing is analyzing the problem. The first thing is analyzing the problem, how we are going to analyze. So understand what the problem is asking. First thing, what the problem is asking. Then identify the inputs, what is given, processes, what needs to be happen, and outputs, that is the expected result. So three things we need to focus on. First is identify the inputs. Okay, what are the input we need to give or already given? The process, what we need to do to continue that input, to put that input into convert into process, and finally we get the expected result what we have. If you have given the proper input and we have applied the proper process, then our output should be expected. What we are expecting, that same output we are going to getting. Clarify and any ambiguities by asking questions or breaking the problem into smaller part. Yes, that is a very important point. So whenever you are solving the problem, you need to clarify the problem. How you are need to clarifying? By clarifying the ambiguity, the complexity present in the problem by asking the question, different kind of question related to the problem, or breaking the problem into smaller parts, or you will divide the problem into smaller parts. Suppose I am giving you an example. Suppose you assign one project. The team manager, the team leader is assigning you the project and divide the team. Okay, based on that you need to start your work. So before going to start your work, you need to know the project, you need to know the problem. So how you are going to know? If you ask some question in your mind that how this process will be executed, how that process will be executed, then that thing will come into your mind and you need to develop that thing, that how I am going to doing this thing, or I am going to solve this problem. If you will be arising the question in yourself, then you are able to do that. Otherwise, or you can break that entire project into smaller parts, so that it will be easy for you to perform the different types of part. Means it that should be very easy to you to understand, analyze the problem. Then developing an algorithm. So an algorithm is a step-by-step procedure to solve the problem. So what do you mean by algorithm? It is a step-by-step procedure. Before you are going to before you are going to solve the problem or write the proper coding for any project, you need to develop an algorithm. You need to write some instruction for this, how you can do this problem, how you can solve, what are the instruction we can follow. So that instruction you can write in step by step procedure. It is what algorithm is, and it must be clear, finite and effective. Remember, the algorithm must be clear, it should be finite, it have some finite number of steps, it should not be unlimited steps, and it should be effective, that should be applied properly to the problem. At this stage you don't focus on coding. Remember, just planning the step logically, you will planning the step logically according to you, how this thing should be happen, how to prepare a Maggi, how to prepare rice, how to prepare dal. Okay, so for this normal the instruction steps you are following, that is the logical thing. Same thing, how to develop the banking software, how to develop the shopping software, how to develop the food delivery software. So what are the problems are there, and what are the instructions are there, that you need to carry on. Okay, that is what algorithm. Then coding. So after the algorithm, proper algorithm you design, you can go to the programming language. You can take any kind of programming language to deliver your project to the client. That is the main focus. Which language you are using? You are using C++, you are using Java, you are using Python, which language it may be, but you should follow the algorithm. Algorithm is the framework for you, it is there. By looking to the algorithm, you can go for the coding part. Very specific. Okay, I am going very specific point. Choose appropriate data types, control structures and condition and function. Yes, whenever we are coming to the programming part, these are the small elements we are going through in the programming part, so that what will happen, this whatever the instruction we have written on this algorithm part, it should be very effective. Okay, when we do the coding successfully by looking to the algorithm, so that our problem, whatever the instruction, it will be solved. Ensure the code is readable and modular. Yes, very important point. Ensure that your code is readable, that everyone should have some sense when they are looking back your code, and it's modular. Modular means it will be divided into different smaller parts. That is what coding is. Okay, then come to testing. Run the program. After writing your code, you will run with different test cases, both normal and different conditions. By putting some different conditions, what are the different condition you are going to give on this particular application, that condition you need to check. Okay, by doing the testing process. Verify if the output match the expected result. So you verify what you are expecting and you are getting that or not. That is the main purpose of testing, that expected result and the result exactly came, it is same or it is violated or it is deviated, then we are going to this. Testing helps to detect logical or syntactical errors. So it need to it need to detect the different logical or syntactical errors. What are the errors are there? Okay. Debugging. If there are any kind of errors, that is in the computer science it is called bugs, locate their causes and fix them. Okay, you will be locating the different causes, why these bugs are happening, and you will be going to fixing them. Common bugs include syntax error, runtime errors and logical error. These are the common bugs, these are common errors. Syntax error due to any kind of syntax. You are writing wrong syntax, wrong formula for this proper condition. Runtime error, when you are running the code and there is any kind of runtime issues are there in this program. Okay, and logical error due to the logic. Tools like debuggers, print statements and unit tests can help in the debugging process. Remember that. Debuggers tools, print statements, unit tests, these are the different process we are using for the process of debugging. Clear? For the process of debugging we need to use this one. Okay. Now we will see representation of algorithms. How we can represent the algorithm? We can represent the algorithm in two main ways. One is your flowchart, another one is pseudocode. So whenever we are writing the algorithm, that we need to display through pictorial representation, that is called visual representation of an algorithm, that is called flowchart. That is called what? Flowchart. So a flowchart is a visual diagram showing the flow of the algorithm, how the algorithm is moving. Okay. So these are you can see ovals we can use for start and end. Parallelogram we can use for input and output. Rectangles we can use for the process. Diamonds we can use for decision points. Okay, example you can see here. Start, input two numbers, it is the oval, first one is the oval, start, then input two numbers through parallelograms, then add the numbers through rectangle, display the result through parallelogram, input output you know that in parallelogram, then end. Okay, this is how the flowchart is representing. Then come to pseudocode. Pseudocode is a simple informal way of writing the steps of an algorithm using plain English. So it is an informal way of writing the code. It is simple informal way of writing the steps of an algorithm using plain English and programming like structure. Normal English and programming like structure we are using. It is very simple and informal way of writing the steps. It is easier to convert the pseudocode into actual code. Easier to convert the pseudocode into what? Actual code. It is very easier to you. Example you can see here, SQL copy edit start. You can input number 1, number 2, then sum number 1 plus number 2, then output sum. You can see here, this is what pseudo code. It is very simple and is informal way of writing the steps of an algorithm using the plain English and programming like structure. That is what pseudo code is. Okay, so normal, in the normal language, we are going to write the process or the algorithm what we have designed. Then final one, decomposition. Decomposition is the process of breaking down a complex problem into smaller manageable sub problem. That is what decomposition is. Breaking down a complex problem, large problem will divide into number of sub problem. Each sub problem can be solved independently and then integrate into the main solution. So each problem will divide into, can be solved independently. Each problem, first you will divide the problem into smaller number of steps, then after dividing the smaller number of steps, each problem you need to solve it. Then again it will integrate into the main solution. This method is simplifies understanding, encourages reuse of solution, helps with collaboration. Different parts can be assigned to different people. One example they have given here, you can see building a calculator program. So input module, what are the different modules are there, you can see here. Input module, addition module, subtraction module, display module, and each can be designed and tested separately. So these are the different module we can design for this. After designing this module, what we need to do, we need to test every module and we need to work on it. That is the main motto of the decomposition. Decompose the bigger part of problem into smaller part and use it recursively. Okay, so these are the things we need to our topic for today. If there is any kind of doubt in any topic, you can ask me in the comment line. So thank you for today. Have a nice day. Thank you.